Okay, so I'm recording it now. So this problem we discussed last time, just the problem statement. Today we will solve it, and you can solve together with me. So this is a board traversal problem. Basically, you have a two-dimensional board, something like this, and you have to find out whatever zeros are totally captured by the crosses or O's are captured by the X's, they will be converted into X's, and those O's which are connected to the boundary somehow, they will be saved. And this connection is only vertical or horizontal, left, right, or up, down. There is no diagonal connection. Right? These two are not connected because this O is surrounded by cross, cross, cross. This O is surrounded by cross, 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 and this O, but this O further is surrounded by these crosses, and this O is surrounded by crosses only. So all these three are basically connected to each other, but they three are surrounded by crosses on all the sides. So they will be converted to crosses. And this O will remain because it is connected to the boundary, and this it is below it there is no cross, so this will be saved. So it's like capturing the area. So these crosses are capturing these O's. A region is captured by flipping all O's into X's in that surrounded region. Okay. If this is the input, then this should be the output. Okay, but we are modifying in place. So basically, if this is your input, then this input itself will be changed to this, and the output is none. But just this board is modified in place. Okay, the surrounded regions. Okay, this we have already discussed. Okay, now how do we solve it? So I have defined a class called board traversal for this problem, and then I have defined a function here called solve, and this function takes as input a board, and the output is basically nothing, none, because it modifies this board in place. So when you are passing this board to the solve function, uh, if it is a list or numpy array, then it is modified in place and not returned. We are not returning anything. So how do we approach this problem? So the first thing, okay, I think I can invite answers from you. Do you, anybody wants to uh, give any suggestion that how we approach this problem? Okay, so first of all, you have to write this board traversal class, basically, which is the solution for this problem. And secondly, you are writing a test class. This is basically testing your solution for different cases. Let's say, what will happen if the board looks like this? Is it returning the right answer? What will happen if the board looks like there is an O here as well? And then does that answer match the right answer? Basically, you are testing your code. So these are the test functions. So you're writing test functions like test1, test2, and you can write all those. And this class is basically testing your solution. So these two classes they need to be written. Anybody would like to say how do we start?
So first we find out which one is in majority, like are the O's in majority or are the crosses in majority, and after that is just we form like regions and then do an assessment whether it is near, whether a portion of the region is near the boundary or not, or each of these region is surrounded by those X's or not.
What will the time complexity or big O rotation, big O complexity of that algorithm? What you suggested,
Hmm.
and what will be the space requirements? Right? Your solution is correct, but is it an efficient solution?
Sir, I have a solution. Can I say?
Sure, sure.
So, like if we start the DFS found a boundary, okay, do a DFS from there, from left, right, top, bottom, from left, right, top, like in all the four directions. So, like if we find an O, we make it to A, and we do this for all the boundary elements, and then we after that we have to just, so all the O's that we have made into A, those are the A that will finally be as O in our answer, and all the X's and all the O's remaining will just be the X's. So the time complexity will simply be m cross n, if m is the row and n is the column, and the space complexity will be maximum of stack, that will be like m cross n. Yeah, like
Mm,
it
yeah.
will be linear. Like if you talk in terms of m cross n, so it will be linear.
Okay. So basically, you are saying that we start from the boundary,
Huh,
and then wherever we find an O, we start our traversal from here
huh,
inside towards
huh.
inwards, basically.
Huh. Like in this case, if there is only one O in the boundary, right? This O. So like if we start from here, we won't go anywhere, like because in all the surrounding regions it has X. So what we will do is like we will convert it to A, okay? And in the second process step, what we'll do, like since all the boundary X's have been converted to have been processed, so what we'll do, like all the remaining O's will be converted into X's, and all the A will be connected into O. So like this, this will be our final answer.
Yeah. Yeah. Yes. Good approach. This appears to be a good approach. So let us code. Let us code this approach. How would you like to program it? So first of all, maybe I can define an array. Let us say this is a list of lists. Okay, so let me write the test function here. I will say this will be, so okay, so first let us say here I will say, um, let us say I'm defining something called pt equal to board traversal, and I will say here, let me call it a self.pt, so just some dummy instance of this class. And then here I will say in test one, I will say self.bt uh, dot solve for a particular board. And this board I can define here. It could be, I'll just copy from here. Let's say it's a list of lists. Oh, I have to define it as, anyway, this is just input format which is given to you. Okay. I could also define it as zeros and ones, but okay, let us complete it with this. Okay, so this is my board, and I'm saying here uh, solve board. Now, what this function should do, it should modify the board in place. So basically, you're passing the pointer to the board, and then the board is modified. The contents are modified, and this pointer is still with you. So you can just now check. You can say, okay, my final board should look something like that. So I will just copy from here. So my uh, target target board should be something like this. This should become an X. This should become an X, and this should become an X, right? Right, this should be my target board. Now you can just assert, oops, sorry, that's not. assert now my board, target board. Yeah, that's it. And if it is not there, it will raise an error. And if it is there, then it will not raise an error. Something like that. You can, or else if you want it to return true or false, then you can say return. Basically, if this is true, if they are same, then this means this function returns a true. And here you can say if test1, if it is true, then something print test1 passed. Okay, something like that. So this how do you want to return your output? That is up to you. I can also give marks here. I can say marks equal to 0, and here if test1 is passed, you can say increase my marks plus, let's say I give 50% more marks, 0.5 fraction, and then I will have a test2. Then again, and you return marks. So it is a percentage mark or fraction of marks. So ultimately, if both the tests are passed, then you return 1 mark or 100% marks. Right? So maximum marks are 1. Okay, something like that. I have not defined any test2 here yet. Just a dummy test. You can create some other test cases, different sizes of the board or different configurations of the board, right? Okay, let's now come back to our original problem. So now we know our board is a list of lists. Now, what do? I have to first, let's say first I define a variable self dot board. Basically, I want to create more functions. So my function could be, okay. So what I need to do here first is go along the border, right? And then what am I going to do is now pick an O, right? And traverse connected O's. Okay. Okay, let's start with that. How do I do it? I will say for I in range, basically I want to go along the length of length and breadth, or basically the boundary. So I will say, how will that be possible? The first row, let us say range 1 to the length of the row. How do you get the length of the row? Okay, for that I have to say maybe self dot m is equal to length of self dot board and self dot n. It's an m cross n matrix, let us say length of self dot board 0, right? So this is the number of columns, this is number of rows. Okay, m cross n. Now I in the range, I want to do all the columns and the first row. I in the range self dot. Okay, so okay, I is the column. Let's say first column and all the rows. So I in this now. Am I doing? This is the number of rows. This is the number of columns. Okay. M cross n. Okay, this is correct. Now I is, let's say I'm going through all the rows of the first column and the last column. So my j for j in basically in the first column and the last column. Last column will be self dot n minus 1. Correct? Okay. Then what I'm doing is so I have to do these are I'm covering the two columns, to the first column and the last column. And what am I doing there? I have to traverse. Let me define a function self dot so you have to pick an O and traverse the connected O's. So, okay, pick and traverse some function which basically starts from your board I comma j. Let us say I pass on the position called I comma j, right? So it will check if this position is an O, then do that traversal. If it is not an O, then just skip, right? So now I have to write this function. Okay, so let me first write down the characteristics of this function. This function should, what it should do, it should check if this is an O, and this is an O, and if yes, then traverse inwards. Okay, and what it should return, basically it should just modify the board, right? Modify board accordingly. Okay. So assuming it will do the task, so this function will do its task. Now I have covered the two columns, I have to cover the two rows also. For I in, basically now I is just the first and the last, 0 comma self dot m minus 1. For j in, now our j's are all the columns, but remember the first and the last columns are already covered. So the range will be not starting from 0, but starting from 1 comma, and the last element also is skipped. So self dot n minus 1, right? So, and what do we do in this? We have to just repeat the same function, self dot pick and traverse. Okay, and once it is done, so okay, I am not passing the board now. See why I am not passing the board. I'm just passing the position because the board is already a class variable. It is visible to all the functions. This board is visible, m is visible, n is visible to all the functions within this class. So I'm not passing them to this function. Okay, now let's say if this is done, then what do? I have to return something. What do I return? I'm not returning anything, but I'm modifying this board in place. So basically this board, I think it is not required because, okay, let us see anyways. So, and then I want to print and see if actually what I am getting. So I can print the board, right? And then just return nothing. Okay, so that is it. This is my algorithm. What is lacking now? This function is lacking, right? I have to write this function now. Okay, what do? I will say define this function pick and traverse self comma. It's the position I comma j. So let's say the index I comma j. It's a tuple. So I will break down I comma j equal to index. So I've gotten I comma j here. Now what do? Uh, what do? I have to see if I find an O. Okay, let's see if I find an O. So I will say okay, if this element is O, if my board self dot board I comma j, sorry, it should have been like this, I comma j equal to O. If this is O, then only we should do this task, this traversal, otherwise not. Then you have to do something, otherwise nothing, otherwise we just return, right? We can move this condition here also, like before starting the traversal itself. That will save our entering this function and doing. So maybe let me move it. I'll say here, if this is O, then only you pick and traverse, right? So there's no need to check, right? Okay, and similarly here also, right? Then I need not add it here. So I'm sure that this index is definitely O, but what about the connected indices? So first I have to get hold of the neighbors, right? I have to get the neighbors and I have to check if any of those neighbors, so these are the left, right, top, down, right? Left, right, top or bottom neighbors. And I have to check if any of those is an O. If any of those is an O, then you can traverse starting from there. So what I will do is I can put them in a stack actually, right? I can put them in a stack, or I can do a recursive solution. I will say for neighbor in, now for a given node, how do I get the neighbors? Maybe I can write another function which will, given a node, I can find the neighbors. So in some function self dot get neighbors, right? Starting from the index I comma j, it could be I comma j or index, whatever, I comma j. Then I can say, so this function should return, what should it return? My get neighbors should return a list of indices of all neighbors. Okay, and then I will say my neighbor I1 comma j1, let us say something, is equal to neighbor, that neighbor index. And then I will repeat this same process. So if board position if my board at this I1 comma J1 is equal to O, then I will pick and traverse starting from I1 comma J1. Right? Right? That's it. So now, but okay, what am I doing here? Okay, what am I doing? So when I'm visiting a node, and if it is O, I have to somewhere modify. Okay, so our algorithm was start from all crosses, and wherever you hit an O, you modify accordingly, right? So let us here define a new board, or the output board equal to something of, okay, new board is made up of all X for I in range self dot m for j in no how do I say list of lists for j in range self dot n, right? Something like this. So I have defined a new board which has all crosses in the beginning, and whenever you hit a valid 0 here, then you modify this cross into a 0, right? So how do I do that? So whenever I hit it, I have to modify. So I'll say self dot new board equal to what? Equal to no, only this entry ij will change. Ij will become an O. Oh, okay. So and finally you want to return the new board. Yeah. Yes. Okay. Yeah. And okay, so what next? Are we done? Okay, so let's I'm feeling a little lost, so let us revisit what we have done. So we have defined a new board which is all full of crosses. Whenever we hit an O in this old board, in the input board, I will modify my new board. I'll put a 0 there, an O there, and then I will move on to the new branches. Here also, pick and traverse. I hit one O in the original board. Accordingly, I modified the new board to an O, and then I collected all the neighbors of this previous input board. And if any of those is an O, then I will again do pick and traverse from that node. So that node will basically convert it into an O, convert the 0 into an O. But now there is a risk. Okay, let us say we assume that we have finished our algorithm. Let us do a small testing, and that will tell us if there is any lacuna. Okay, okay, but here there is one function which we need to define. Okay, let us define it first. Define get neighbors. Self comma index. So this is very simple. So my first of all I comma j is I break down my index into the I comma j, and then I have to return neighbors, the indices, right? So let us first initialize our neighbors with an empty list, and now I will say if okay, now I know I minus 1 and I plus 1, j minus 1, j plus 1, these are all left right neighbors, right? So I can return simply here I comma j plus 1 comma I comma j minus 1 comma I plus 1 comma j comma I minus 1 comma j, right? These are the 4 neighbors, top, bottom, left, right. But what is the problem? If we are in the boundary, then there is no left neighbor or no right neighbor or no top and down bottom neighbors. So we have to do a check. If my if I minus 1, so basically for, let us say, start from the first one, my j plus 1 has to be less than the maximum value, then only this neighbor is valid. So if j plus 1 is less than self dot n, right? J upper limit is n minus 1, so it is less than n. Basically it can be up to n minus 1. Then only you do neighbors dot append I comma j plus 1, right? So it won't be like this. And if j minus 1 is greater than or equal to 0, then only you do neighbors dot append what I comma j plus 1. So I and I comma j plus 1 is a tuple. So this is a tuple, and I am appending this tuple to this list. And similarly, if I plus 1 is less than self dot n or m, sorry, m, then you do neighbors dot append I plus 1 comma j. And if I minus 1 is greater than or equal to 0, then you do neighbors dot append I minus 1 comma j, right? And then you're returning the neighbors. Okay, so this is our function. Let us now do our test here first. So to be more clear, what I will do is I will do a print here. Print the board, and after running this, I'm again printing my board. Save. Let us try to run it now. Will it run? No, it will not run because I'm not calling this class, which I want to. Okay. It is always a good practice to because if I'm calling this whole file as a module in some other uh, file, then this always is helpful. Anyway, this is IPython. Here it doesn't matter, but in Python it does matter. So I will just say here, let us define a test class. What is it called? Test TBT. Let us say test board traversal equal to test board traversal. And I think just by initializing it, automatically the test is performed. So I think that is it. We don't need to do anything else. Let us run it. Okay, it says test1 is not defined. Okay, why it is not defined? Because self.test1. Okay, and we got some good error. This is not printing properly. What we can do is we can print np.array. And we have to define numpy also. I will say import numpy as np. Okay, let's run it now. Okay, see it prints nicely now. This was the input board, and then we got some error. What is the error? So we start from here, board traversal, and here self.test1, and here it says self.bt.solve board, and here it says self.board I comma j. Okay, it says that list indices must be integers or slices. Okay, I'm treating it as a numpy array. That is not good. So it wants me to treat it as a list of lists, just like we have done the indexing. Okay, I think this was a very silly mistake. Like this, ij. And similarly here, ij. Yeah, so whenever we are accessing the entries of lists, we have to access it like this. Okay, let us run it again now. And another error. in similar position. Oh, same kind of error. Self dot board I comma j. Okay, let us run it again. Okay, init should none, not float. Oh. Okay, it is returning marks. Okay, let me modify it a bit. Define, evaluate some function. Okay, let us leave it like this. We're just printing the marks. Don't return marks. Just print marks. Okay, so we're just printing the marks. Oh, test is passed. That is strange. We passed the test. Marks obtained is 0.5. No. The mark, no, it is not correct. The answer is wrong. The answer is wrong. Why is it wrong? What is this? We are printing something else as well. We're printing board somewhere else as well. That is why it is showing that extra entry. Oh, here it is doing it. Okay, it is doing printing the board. That is the same board which is being printed. This one is all 0 zeros. Okay, because we modified it. Oh. Okay, let us see what is the mistake. Print board. Okay, let me. Okay, I don't know what is the mistake. Let us return a board. Instead of modifying in place, I'm just returning the new board. Okay, returning the board. Just modification of small modification here. This will be the new. Okay, let us run it now. Oh yes, yes. Now it is doing it. Actually, there was the problem with the pointers. Now it is correct. Now it seems correct. But there is one. Okay. Anybody has any questions at this moment? Let me open the chat window and see. Or you can speak out as well. Will coding quizzes be in Python, or will we be allowed to use other languages like C++? The answer is we will prefer Python only, because all the tools which we use for machine learning, mostly they are in Python. I don't know if do you know any libraries in C++ which do deep networks, deep learning? Could you answer the question? Do you know any libraries in C++ which do? Okay, no, fine. Yeah, that's why I wanted that you get good practice in Python, and feel free to use any data structures which are inbuilt in Python. If some data structure is not allowed, we will mention explicitly that do not use. Let us say if you are implementing that DEQ in that assignment, don't use the DEQ directly from Python, but you implement it on your own using other data structures like list or uh, whatever you want. Okay, and actually list also will be very simple. Maybe you define a class and then connect the nodes. That could be. Okay, so this is doing the task, but there may be some mistakes, right? For example, if there is, okay, Let me define a test 2 in this way. In the test 2, let us say this is also an O. So now this will go here. This will have two neighbors, this one and this one. And from this neighbor, it will go on and it will loop unto itself. And from here, it will also loop unto itself. So there is basically circular connectivity. And can our code handle this circular connectivity case as well? Let us check. So our output should be, in this case, it should be what? It should be all O's, right? Right? If this is the input, this should be the output. I fear that our algorithm might get stuck in this circular loop, right? Because when it finds the neighbor, which is 0 or O, then it will find all its neighbors and it just traverses it. There is no way to know whether this neighbor has already been picked by some other through some other route. So that is one problem I see. Let us test it. Okay, it is test 1 is passed and test 2 is stuck. So my algorithm is stuck, you see. I was fearing this. See, it is running and running and running. It has gone into an infinite loop. Okay, finally it has come out. It seems recursion error. Maximum recursion depth exceeded in comparison. Basically, you have hit an infinite loop. Basically, I think you got the point that when you are using uh, uh, when we are using this loop traversal, we are kind of in the recursive traversal, we are stuck in that circular loop and recursion is going on and on. So we have to find some way to how do we do you have any idea how can we avoid this traversal?
Sir, we can maintain a list of nodes that we have visited.
Very good. Yeah, so that means we have to maintain another list, and then every time we visit a loop, visit a node, we have to check whether that node has been visited a priori or not, right?
Yes, sir.
Anything any better solution? Okay, there is one solution on the chat board. Convert O to X after visiting once. Okay, basically we have our old board. If in our old board, whenever we visit um, a point or a node, we just convert it into X so that this node is done basically, right? Because we are not visiting the X nodes. We are only interested in the O nodes. So once you visit something, you don't let it remain an O node. Yeah, so yes, this is a good solution. Let us try that. So when we visit a node, then on our old board, self.board ij, we make it an X. Earlier it was an O, but we make it an X. Okay, we have visited it. We don't want to visit it again. Okay. Let us try it now. Yes, it works. See, now once you visit, let's say, okay, once you start from here, you visit this node. This node becomes an X. You visit this node, it becomes an X. You have this neighbor and this neighbor. Let us say you go in this direction, you go in this direction. This becomes an X later. This becomes an X later, and then you go to this one. This is also an X. So you are kind of saved from going into an infinite recursion. Okay. So yeah, I think yes. Now you are welcome to create more difficult test cases, right? And that, for example, like we formed this test case. It was a good test case, but it didn't cover one possibility. and this test case covers that possibility too. So like that, you can create more tests, create bigger test boards, bigger boards, bigger test cases, and that way you can find out if your algorithm is able to handle all those situations efficiently. Okay, so that is it from my side for today. Like this, you can solve the assignment problems and do interesting stuff. There is a question on the chat board: can we use C++ for data structures and algorithms? I think don't use that. I don't want to confuse people. Let's stick to only one language, Python. Let's do it in Python only. Anybody has any problem with that if we stick only to Python? Because then uh, for us also evaluation becomes easy. We can just uh, evaluate in the same language. We don't have to go over multiple languages. Okay, I think we stick to Python.
Sir, I wanted to say something that like could you please upload each lecture video after the lecture immediately, because sometimes it happens that our internet connection fades away and then we miss out something, and then it becomes difficult to follow on the lecture from that point, and then it becomes confusing a bit. So
Okay.
could you please upload the lecture video immediately after? And plus the point is, if you